So our next example, we're going to be finding the equation of a line perpendicular to a given line. It says line N through point P. Our problem has line L through point P. So again, whatever they name the line of the point doesn't really matter. You have a line, you have a point. All right. So first you find the slope of the line, again, depending on how they feed you the information. If they give you 2 points, use the slope formula. If they actually give you a picture of the line, you do rise over run. They give you an equation, it's the number in front of x. So however you need to find the slope. And then this is the different step. This is the one thing that's different in the technique. We're going to make the perpendicular slope. And the relationship between the slope and the perpendicular slope, according to the book and the theorem, is that the slope and its perpendicular slope multiply to make -1. The end result of that thought is it's just the opposite reciprocal. So whatever this slope is, fraction or non-fraction, if it's non-fraction, put it over 1. Flip it over and then change the sign. So, for example, if the original slope is 2/3, the perpendicular slope is going to be -3/2. If the original slope is -3, the perpendicular slope is going to be +1/3. If the original slope is 1/7, the perpendicular slope will be -7 over 1, or just -7. All right. Whatever fractional structure the original slope is, flip it over and then change the sign to its opposite. That's how you make a perpendicular slope. So that's all step 2 is going to be. Once we find that, we take whatever the fraction or non-fraction look is, reciprocate, and change the sign. And then this also is slightly different. We're replacing the perpendicular slope. So once we find this, I usually strike this one out in my work. I find the slope somewhere, I make the perpendicular slope, then I strike that out so I don't want to use it. Because once I've done step 2, this slope is no longer of importance to me. All right? So I'm going to replace the perpendicular slope, that'll be M, and X and Y into this, and the X and Y from point P into the Y equals mx plus B equation, solve for B, and then replace this slope and this Y-intercept. It says slope from step 2. Yeah, so step 2. So here we go. We have our line. Same line looks like, doesn't it? Yeah. All right. May not want to draw a different picture, I think. But anyway, here's our line. Here's our point. We want the perpendicular line to be coming through this way. And my slope, I'm going up 1 and I'm going right 2. So my slope of line L is going to equal 1/2. Yeah, step 1 is just as it was before. Find the slope of the line you're looking at. Then step 2, the perpendicular slope is going to be -2 over 1, better known as -2. Anytime you get over 1, when you're doing the algebra part of this, I don't put the over 1 because fractions aren't as easy to look at as integers. So I prefer to have an integer look if I can. If it ends up being a fraction, so be it. All right, but the perpendicular slope, this is the notation for perpendicular slope here. So it's got the little perpendicular symbol. And again, once I find that, I usually strike this out so I'm not looking at it anymore. That will no longer be of any importance to me. Still leave a little remnant of it so I can actually see that I did it, but get that out of your mind at this point. Okay, step 3, we have our slope and then we have our point P, which is 4,1. And again, this is the M, this is the X, and this is the Y that we're going to put into Y equals mx plus B. Y is 1, M is -2, X is +4, and B is what we don't know. So we substitute everything we do know in to find the one thing we don't know. -2 times 4 is -8. A negative number is going to chop off this side, become a positive number, so we're going to get 9 equals B. And now the slope that we're using is -2. The y-intercept is +9. And again, this is my structure, my answer. I want to replace these two values with the M and B that I found. So my answer is going to be y equals -2x plus 9.